Hello, Explorations in Math students. This is Professor Roldan. This video is going to be for the live synchronous review session that I tried to record last night, but it did not work out for me. So here is the full video. There are no students. This is not a meeting. This is just me recording this assignment for you. So all you have to do is print this out. You should have this attached to an email and also an assignment in Word version and also in PDF. So you can fill it out however you need to, or you can do it on a separate sheet of paper. So to get points for this, you need to have it filled out and sent to me through email, as discussed in the previous announcements. Okay, so for the final exam, you have 25 questions. And you have 90 minutes. And so this outline is going to provide for you the specific topics that are going to be assessed on the final exam from each chapter. So this is cumulative, so we have questions from chapter 4, 6, 10, 13, and 14. So let's get started. So with chapter 4, we have 4.1, and we have the Roman numeral review. Okay, so the main points to remember here would be that there were many rules to remember from the previous video that I made on this, but for the purposes of the final exam, I think the first two should be fine. Okay, so basically it's the basics, which means you're going to add numerals from left to right, unless the value is smaller than the value of the numeral to the right. Okay, so what do you do in that case? Well, that's step 2. If the numeral on the left is smaller than the numeral on the right, then you're going to subtract instead of add its value from the numeral on the right. Okay, so let's take a look at an example here. So if we have L, X, X, I, and X, we're going to be adding unless the numeral is smaller than the one on the right. So when we take a look at this, we have this L is 50, and we have 2 X's, so that's 10 plus 10 is 20. And then we have a 1 or an I in front of the X, so that's going to be 1 minus 1 taken away from 10, so that's going to be 9. So the answer is going to be 79. Okay, so let's take a look at 4.3, which is to convert a given numeral to a numeral in base 10. So remember that you're going to be using the expanded notation of position values. So for example, if we have 208 base 12, then you're going to be separating each position with its proper value. Okay, the ones place is always, the same for all bases, so that's just 8, but really it's 8 times 1. There is nothing in the middle value, but if there was, it would be that value times 12, since we're on base 12. And then the third position is going to be 12 squared in this case. So there's 2 sets of 12 squares. So that's 2 times 144, which is 288. This is 0, and this is 8. So the final answer will be 296. So in 4.4, add numerals and other bases other than 10. The main thing is to make an answer key, okay? And the way you do that is to count in other bases. Okay, so if we have 133 base 6 plus 44 base 6, well, you can't just start adding. You have to know how to count in base 6. So we're going to go ahead and count 1, 2, 3, 4, 5. And then when you make a complete set of 6, you have to now move to the second position because this is place value. So now there's one complete set of 6 with no remainders. That's 1, 0. And now the 7th item is going to be 1, 1 because that's 6 and an extra. 6 and 2 extra is going to be 1, 2, and you just continue this process until you get 2 sets of 6. That's going to be 2, 0. Okay, so that's my answer key. So now I'm going to say, okay, I'm going to start adding the first column, 3 plus 4. That's 7 items if we were counting, but the 7th item in base 6 would be right here. Okay, that's the 7th item. All right, 7th count. So that's going to be 1, carry the 1. And now I have 8 items. So the 8th symbol, the 8th item is going to be 1, 2. So I'm going to put the 2, carry the 1. And now 1 plus 1 is 2. And the second item is just a 2. And that's now base 6. So now we're going to do 4.5 as we wrap up chapter 4. You're going to multiply using an interesting concept, the duplation and mediation. So remember that duplation means to multiply by 2 and mediation means to divide by 2. But actually you do the dividing first. So we're going to divide on the left side by 2, drop any remainders, and then multiply the right side by 2. Third step would be to cross out any rows with even numbers on the left side, and then add all remaining numbers on the right side. Okay, so let's take a look at an example like 19 times 19. So we're going to make 2 columns here. We're going to do division on the right, the left, and multiplication on the right. So we're going to start with our numbers, and then divide by 2, and we're going to drop the remainders or the decimal parts. So 19 divided by 2 is 14 and a half. We're going to drop the half part. I'm sorry. I meant 9 and a half. So drop the 9. 9 divided by 2 is 4 and a half. We're going to write the 4, drop the 0.5, and we're going to divide this by 2, and then divide this by 2, and you stop when you get to 1. Now we're going to multiply the right side by 2, so 19 times 2 is 38. 38 times 2 is 76. 76 times 2 is 152. And then 304. So that's steps 1 and 2. Steps 3 would be to cross out even numbers on the left side, the whole row. So I see a 4. That's the whole row is going to get crossed out. A 2. So I'm going to be adding the remaining 3 numbers on the right. And if you add those up, you get 361. Now, if we do the lattice method, the same thing. If we do 19 times 19, we can do our little box here. Each number gets its own column, and then each number gets its own row. And then we do our little diagonal. And now we start multiplying. So 1 times 1 is 1, so we're going to put a 0, 1 here. 9 times 1 is 9, so we're going to put a 0, 9 here. 1 times 9 is 0, 9, and then 9 times 9 is 81. So 8 and 1. So now we're going to add each diagonal. So this is going to be a 1. So these three numbers here, that's going to be, what is that? 17 plus 9, 26. Carry the 2 over here. So we're going to add 2 and the 1, and that's going to make 3. And we're 361. Okay, let's take a look at chapter 6. We're going to start with 6.2, which use a linear formula. We're going to use a given number to substitute into the formula, and then just remember the order of operations, okay? So remember that there's parentheses first, then you do exponents second, then you multiply or divide, whichever one comes first, and then you add or subtract, whichever one comes first, from left to right. Okay, so if we have, let's say Fahrenheit equals 23 degrees. Sorry. Convert to Celsius. Well, there's a formula. Celsius equals 5/9 times Fahrenheit minus 32. So we're just going to plug in the 23 for Fahrenheit right there where the F is. Okay. And then we're going to do our calculations. So we're going to do what's in the parentheses first, which is going to give us -9. And then we can go ahead and cancel out those two 9s, because that makes a 1. And that's going to give us -5 degrees Celsius. Next, let's take a look at 6.10, which is very similar. It says use an exponential formula. Population growth after t years. So 6.10 is in terms of functions. So let's say we had a population function, P of t equals 4,000 times 1.3 raised to the 0.1 t power. And let's investigate 6 years. So that means we're going to take 6 and we're going to put it into the function or formula. So we're going to say, if we're putting 6 into the function, that says P of 6, we're going to put this 6 right here and calculate. And let the calculator do all the work for us. Okay? Now you could do the exponential part up there, so that would be 0.6. And you can let the scientific calculator do that for you. Okay, so I recommend using desmos.com/scientific. The link is provided for you in MyFire. And basically, it's going to look like this. So you type it in exactly the way it looks. You can even do the first line like I did there with the 0.1 times 6. And it gives you the answer 4,681.94. Highly recommend you use that resource for you. So again, this is desmos.com/scientific, or use the app. So 4,681.94. Next, let's take a look at 6.6 in graphing linear equations. So let's say we have this is our general form of the linear equation. Remember that this is the slope and this is the y-intercept. And so if we have an equation like y equals negative 1/3 x minus 4, we can quickly graph our first point, which would be 0, negative 4, right here. And then this is going to help us move, because that's our slope. And remember, this is rise over run. So we're going to go down 1 and over 3. So from that point, we're going to go down 1 and over 3, right here. And then just connect the dots. Now, you can use desmos.com as well to help you out with this. And it looks like this. Now, this is not the scientific version. This is just desmos.com, and then click Start Graphing. Okay, so here it is. You type it in exactly the way you see it with the menu below, and then you can see that you need a point right here, and you can pretty much pick this point right here to verify. But you can use it to check your answer or to get you started. Next, determine the equation from a graph. So here's our graph, and we're going to try to gather the information for our slope-intercept formula. So we need our b term, which is right there. That's 0, negative 2, so that means that b is negative 2. So we know that this is going to be negative 2. And then we need our slope, which is going to go from up 2 and over 5. So, I mean, the only way you can get that wrong is if you do 5 over 2, which is upside down. But basically, you're going to use those two numbers, the vertical change and the horizontal change. Okay, next we have 6.7, solve the system of equations by graphing. So we're going to do 2 equations at a time. Before we do that, let me remind you that if the 2 lines intersect, and that gives you a solution. So basically, that's called consistent system because they're intersecting. If they don't intersect, that means they're parallel. So that would be an inconsistent system. Because they're parallel. And then if two lines are, the equations look different, but an actual, you simplify, you're going to get the same exact equation once you do that. That means you're going to be drawing lines on top of each other, so it's basically the same line. That's called a dependent system because they're the same. Okay. So sometimes you have a multiple choice question after you graph it that you have to answer one of those. So let's say we have to graph x plus 2y equals 0 and 2x plus 6y equals negative 30. If we have to graph those, there's a couple of different methods you can do. You can look at previous videos or the textbook for that. I'm going to go ahead and give you the Desmos.com method. Basically, you're just going to go to Desmos.com and type it in. Okay. So those are our two equations right here. And as you can see, the solution is the intersection, the ordered pair negative 6, 3. Next we have 6.8, which is also two lines, but they're going to be inequalities. So there's a couple things we have to remember. And so when you type this in MyLab, you're going to have to choose a couple options. Number one, it wants to know that are you going to click on the solid line or the dashed line, okay? So solid line has the equals and the dashed line does not have an equal sign. So it would be this one or this one. Okay. Next, you have to shade above or below the line. So you're going to have to use the paint button to shade above or below. Oh wait, paint, yeah, paint button. So use the paint button. Okay. So Desmos, once you type the inequality, it knows to shade above or below. It also knows if it's solid or dashed. Okay, so here is, sorry I didn't put that over here. So x minus 2y is greater than or equal to 8. And then y is greater than negative x plus 3. And you just type it exactly the way you see it right there. And you will see the the shaded regions. And then, of course, the overlap. In MyLab, you're only going to see, you will see the overlap right here. Okay. So this would be the solution, and you'll be done. Okay, so also in 6.8, you also have the application of linear inequalities, which is linear programming, and this is to find the maximum and minimum values of the objective function. So we have k equals 10x plus 3y, and we have our looks like we have 4 vertices here. And so you have to use each vertice or not, it's each vertex, but let me do each of the vertices. Which are ordered pairs. So we're going to use this for the function, okay? So we're going to put in 0, 0. Doesn't matter which order you do this in. Then we're going to do 0, 5. Then 6, 2. And 7, 0. And we're going to use our objective function, which has the 10. So we're going to repeat this process with each ordered pairs. So 0, 0, 0, 5, 6, 2, and 7, 0. Okay. So 0 plus 0, that's going to be 0. Then 0 plus 15 is 15. 60 plus 6, that's 66. And then we have 70 plus 0, which is 70. So here you can see our minimum, our maximum. So we have a maximum at 7, 0 with the value of 70. And we have a minimum at 0, 0 with the value of 0. Okay, this concludes the first part of this review, which is chapter 4 and 6. In the next video, in part 2, you will see chapters 10, 13, and 14.